as I said in the introduction video for this lab number 3, we are going to go over the lab manual together, and then I'm going to provide you with the data and also the instructions to how to complete this lab. As I said before, in this lab, we are going to find the properties of the multi-component hydrocarbon fluids from the reservoir condition all the way to atmospheric condition. So our petroleum reservoir fluid at this experiment contains propane, hexane, and methane. We are going to have 20% propane, 40% hexane, and 40% methane presented in our visual cell. Then what we are going to do is we are going to collect some information at every single step of this experiment, which is basically provided as a data sheets at the end of your lab manual. So these are the data sheets for the simulator that we are going to collect. So when we start this lab, we are going to collect our initial condition. What would be the cell temperature, ambient temperature, initial pressure, and initial volumes. We are going to look at the composition of our cell to make sure that we are working with the right experiment. And then, as I said before, we are going to find the bubble point pressure using the flash vaporization test. In the flash vaporization test, we are going to find the bubble point pressure and the relative volumes. So what we are going to do, we are going to, exactly like what we did in lab number 1 and 2, we are going to remove some mercury from the cell. And every time we remove the mercury, we measure the total fluid volume in the cell, and we are looking for indication of having the first gas bubble. So when the first gas bubble presented as a smallest volume of gas that we can detect, then we record the pressure associated with that bubble point and the total volume of the bubble point. That's basically our flash vaporization test. So when we are done with the flash vaporization test, we are going to complete the second task. So here we need to show how much volume we have drawn. There is this test here. Basically, it says bubble point pressure before and bubble point pressure after shaking. You just want to show you if you don't shake the cell every time you add or you remove mercury, the readings would be different. So you must shake the cell every time you add or you remove mercury. And then we will collect the cell, contain the amount of liquid and vapor, and then we are going to look at the gas chromatography of the fluid at the bubble point. The initial gas chromatography is basically just going to show the composition in the liquid, because initially we just have the liquid. However, when you obtain the bubble point, since you have the first gas bubble, it also gives you the composition of the gas as well. So this becomes our first experiment, which is exactly the same as experiment number 1 and 2 that we have done previously. And that's our flash vaporization test. Remember, the numbers that we are going to collect here is the bubble point pressure and the volume associated with bubble point pressure. We are going to use this volume to normalize all the volume, all the liquid volume measurement that we are going to do later on, okay? So when we are done with the flash vaporization test, the next test that we are going to do is the liquid expansion test, okay? So in the liquid expansion test, what we are going to do is, actually we're going to load another program which basically gives me the 60 cc's of the liquid, okay? Because I want to send a liquid from the lower pad. So we have two pads here. There's upper pad, which we usually use for gas expansion, and there's a lower pad, which we are going to use the liquid expansion. So in this experiment, if I'm going to do the liquid expansion, I'm going to send the liquid out from through valve 14, going to valve 16. Then I have D2, which is a density meter. It's just going to measure the density of the liquid that I'm going to send out. And also I have a back pressure regulator. So the back pressure regulator is a valve. It's a safety valve. We always use in experiments to make sure the pressure in the cell is not changing. So if I want to keep the pressure being equal, let's say 3000 psi, then I set the back pressure regulator 3000. Then what does that mean is, all the way from the left side of this valve, all the way to the cell, the pressure will stay 3000. If for any reason the pressure in the cell goes above 3000, this valve opens up and releases the excess pressure. So it still keeps the 3000 psi here. Anything above, it's just going to open, okay, and release that pressure. So when it opens, Then the liquid will going to collect it at the centrifuge. So this is going to act like our stock tank. So we are going to collect the liquid here, and the gas is going to go to our gas vessel. Okay. So remember, here it shows the gas vessel has a pressure of 14.7 psi, which means it has air in it. Before doing the experiment of the liquid expansion, we just want to make sure that we put vacuum on this and get rid of all these pressures. We just don't want to have the air in the cell. We don't want the gas to get mixed with the air. So we are going to put the vacuum on this, empty the cell, collect the gas in the gas vessel, and then we are going to use the helium tank to send the gas vessel to the gas chromatograph and come up with the composition of the gas that we collected. When we have the liquid collected, in this brown box, we also can collect the mass of the liquid that we collected. So the mass of oil will be collected, the pressure of the gas will be collected, the composition of the gases will be collected, and the density of the liquid also. So density of the liquid, mass of the liquid will be collected, composition of the gas, and pressure of the gas will be collected. So these are the information that we are going to collect using the liquid expansion test. So it says what you are going to do with the back pressure regulator. So definitely, since this experiment, the separator test or liquid expansion test starts from the bubble point pressure, we always wanted to have this pressure to be equal to the bubble point pressure. Remember, the back pressure regulator doesn't have any decimals. So if your bubble point pressure turns out to be 1391.2, then you need to round it up. So, and we are going to round it to the upper number. So if it's 1391.2, we're going to set the back pressure regulator to 1392, okay? But if it's the exact number, then we are going to use the exact number, okay? So we put the back pressure regulator, we measure the liquid density, measured with D2, and then here to send the liquid out, instead of using hand pump, we are going to use the servo pump. The beauty of using servo pump is it's going to give you the chance to pick the rate and the amount. For example, I want to say, hey, I want to send 6 cc's of liquid out of this cell with the rate of 1 cc per minute or 2 cc's per minute. So I can set the amount and I can set the rate. Here it says what type of rate and what type of amount you picked for sending the liquid out. And then it says what would be the gas vessel pressure when you send this liquid out, how much gas will be released. So we collect the gas and we collect the amount of mass of liquid. And at the end, it says, what is the gas chromatography of the gas? So we find that. So this step basically helps us to complete the liquid expansion test. So again, if I want to do this experiment, so I open valve 14, I collect the pressure. I open valve 8, I open valve 6, and I open valve 18. So I'll open all the paths from the bottom. I set the back pressure regulator to the bubble point pressure, whatever pressure I found from my flash vaporization test. As I said, if that number has some decimals, I just round it up, okay? And then I'm going to use F8 to put the vacuum. So if you press F8, it's gonna put the vacuum on this helium cell, and it's gonna just simply evacuate this. This pressure goes to 0. Make sure there is no air in it. So I make sure there is no air in this one. I make sure the pressure is equal to the back pressure regulator. And then I go to my servo pump. For example, I say I want to send 6 cc's of the liquid out. So I set the amount of delivery liquid to be 6. And I wanted to do it in, let's say, 1 cc per minute or 10 cc per minute. Okay? So that basically gives us the time. And then if I press F4, this servo pump is going to inject that amount. Since I'm injecting fluid inside the cell, the pressure starts going up, but as soon as it goes above the bubble point, the back pressure regulator opens up and it releases the liquid. Meanwhile, I can calculate, I can read the density, I can read the mass, and then when the gas is accumulated in this gas vessel, I'm going to close valve 19, open valve 20, open valve 21, and I'm going to press F9 to activate the gas chromatograph. Basically, if you press F9, it's going to send the helium to the visual cell and send to the gas vessel, and then it's going to carry the gas to the gas chromatograph. And then you press F10, it gives you the gas composition, and you're done. So here, at this point, you are done with the flash vaporization test, and you are done with the liquid expansion test or separator test. So this gives you enough information to perform the calculations for the uh, liquid expansion, the CPs, the CBF, and also initial solution gas oil ratio. So how are we going to do that? I'll go over the instruction, but briefly speaking, the amount of for the CBF, we need to know what's the amount of liquid we are sending out and what's the amount of liquid we are collecting at the end. Okay, so remember the composition of the liquid, we can find it through the gas chromatograph. So we do have the composition. Okay, so if I have the composition, the density of all these components at atmospheric condition is a fixed number. I know what is the density of methane, propane, or butane, or hexane at a standard condition. This is given at the end of the book in table A1. Okay, so I have the density. Okay, so I have the density, I have their mole fractions. I can find the average density of this mixture. Okay, this is basically weighted average of the density of all the components. So I have the composition of methane, I have the density of methane at the standard condition. I have composition of propane and I have the density. I have composition of hexane and I have the density of hexane. So I can multiply and I can average the density of the mixture at a standard condition. I have the mass of liquid as well. So I have the density, I have the mass, I can find the volume. So that basically gives me the volume of the liquid at a standard condition. I know how much volume I have expelled. I have just sent out of the cell. That's my volume at the reservoir. So I can find the CBF. So the same calculation we can do for the gas. Again, the gas composition is given, the mass of gas is given. I can find the volume of gas. And then when I have the volume of gas at a standard condition, I can find divided by volume of the liquid at a standard condition and get the initial solution gas oil ratio. Again, the instruction will be posted on how to perform this test. So after we are done with this, we are going to perform the gas expansion test. The gas expansion test will be done in 8 stages. But before, we need to collect the initial conditions. Again, for this, since we are going to use the upper part of the cell, again, we are going to load another program. So we are done with the liquid expansion, we exit the program, we load it again. And then this time, we are going to send the gas out. But again, as you remember, we said all these tests will start at the bubble point pressure. So again, we set the back pressure regulator to the bubble point pressure, and then we are going to drop the pressure in the visual cell. We are going to drop the pressure in the visual cells following the table instruction given. Okay, so for the expansions, for our 8 expansions, there is a table given for this differential vaporization test. So for first liberation or for first gas expansion, it says we draw 1.2 cc from the cell. So if we draw 1.2 cc from the cell using the hand pump, the pressure will drop and gas will be released. And then we are going to set the back pressure regulator equal to that pressure because we want to keep the pressure constant. And then it says you can expand this with the servo pump of injecting 1.68 cc. And then we are going to inject 1.68 cc's of mercury to the cell to expand the gas out. Okay, so I'll continue this on the next video, and we'll discuss the differential vaporization test, and we'll follow on the remaining part of the lab.